Well, hello everybody and welcome back. This is just going to be a random video, so some of you might like it, some of you might not. Just feel free to just skip on through. But just I'm working on a big project right now. Actually, I have several, and kind of in the middle of them. I'm waiting on some extra things to come in to finish up, and hopefully we'll have a video out this weekend coming up for my next project. What I have in front of you now is just a little teaser for what's coming up. This first box of massive amount of parts is only partial of an order that I have for a very large project that'll be coming up here in the next couple of weeks. So it should be pretty exciting. Hopefully I'll get a little bit of time from work to be able to get a little spare time in the evenings to work on it. And this one down here is another project that's not quite as big, but it's still going to be a pretty substantial project coming up. And we should have some really interesting videos for them coming up. I hope you like them. I know I'm going to really enjoy doing them. So that's that. Now, what we're also going to spend some time on in this video is a couple things. I have one thing I'm going to show you that came in. It's a novelty type thing that I think is kind of interesting. I thought I'd share with you just to kill some time. And then second of all, I want to try to address a few of the comments and questions. As you noticed, I've been getting a lot of comments lately, and I've been getting even more emails than I can really handle right now with my time. So I thought maybe if I took some time in a separate video, I could at least answer a few of your questions and a few of your comments and so forth. And maybe, because I really feel bad that some of you have asked some really great questions, and you're interested in doing this kind of work, and you're interested in learning some things. And I feel like I'm kind of letting you down by not being able to answer your comments as much as I'd like to. So hopefully I can do that. So without any further ado, let's get on with the next thing. So the first thing I want to kind of show you all and share with you is just a little novelty item that I picked up from the folks at Banggood. They kind of donated it just for putting a link to it on the site. So I'm going to put a link down below on the video that you can actually see this thing. Sorry. Okay, I'm back. So what we have here is what's called a Stirling engine, and I'm sure many, if not all of you out there, have at least heard of these or seen them. They're very popular right now because there's a lot of little companies out in China and so forth that are kind of making models of these, and they're very interesting, and kind of the technology has kind of had a resurgence over the years recently because of some of the ways this thing works, and it kind of interested me. So I thought, it'd be kind of cool. I've never seen one in real life. I thought I'd get one in here and get it on the bench and kind of play with it and kind of see how it works. Now, what a Stirling engine is it kind of reminds me a little bit of a steam engine, but it really works off of kind of a different principle than a steam engine. A steam engine, of course, has a steam valve and uses pressurized steam to drive a piston, and that pressurized piston in the cylinder pushes the push rod, which rotates the crank. We all know how a steam engine works. But these Stirling engines are a little bit different in how they function. And they function based on expansion and contraction of a medium like a gas. In this case, the simplest versions, like these little models that you buy, just work with air. So if you look on this one, I believe, and everybody please correct me if I'm wrong, because I'm not an expert on these. I just read a little bit up on them, and just thought I would have one on the bench to play with. So if you guys know things that I don't, or I misspeak, please feel free to correct me. But you basically have, this is what I believe to be an alpha model. There's alpha, beta, and gamma are the three different designs of Stirling engines, and it's all dependent upon how the cylinders are configured in the unit. This is an alpha, which is the most basic form. You have two cylinders, each with pistons in it, and the cylinders are connected by a connecting gas chamber, I guess you'd call this. This is how the gases can get between the two cylinders. And if you notice down here is a little burner that creates heat, and it will heat the air inside this cylinder. And this cylinder is kind of sealed up, and they actually give you a spare cylinder, little made out of Pyrex or heat resistant glass, and it's sealed with an O-ring in there. And what happens is when we light this, it will heat the air inside this cylinder. That air will expand, and since the air in this side is cooler, that difference will create a pressure difference, and that pressure difference will cause this cylinder to push outwards as the gas expands, and this cylinder to pull inwards as the gas contracts because it's cooler. And that action of hot to cold causes that reciprocating action of the engine. Now, to my understanding, after some reading that I did, is this type of technology can be improved upon based on the gas that's in the cylinder. You'd have to have a totally sealed, pressurized system, but they've used gases such, I believe, hydrogen, believe it or not, even though it's dangerous, any lighter than air gas, helium, I believe they tried nitrogen, different gases that actually have better properties when heated for expanding and contracting than just air. But it's very interesting, and we're going to start this thing up and see how it works. Apparently, if these are designed properly, they can be up to 50% or so efficient at converting that heat energy into mechanical energy, which, when compared to like an internal combustion engine, is actually very, very efficient. Now, the problem is the weight ratio. When you look at how big and heavy these are compared to the actual power that they put out, that makes them not very efficient because of their weight. And that's why you don't see these so often used in practical situations. But here's the thing that kind of intrigued me was I read some articles where these are starting to be developed to be used with geothermal energy, and the temperature down there is warmer than the temperature at the surface of the earth, especially in places where it's cold out. And these cylinders can be installed in that configuration and actually utilize the heat produced by the earth to create that motion. Now, of course, this is not free energy. There is no such thing as free energy. But what it is doing, is converting the energy absorbed from the earth into a mechanical energy. Very fascinating, and I really would love to see one day if somebody develops it to a point where we can actually make electrical generators using this technology. So that's kind of what intrigued me, and that's kind of what got me to at least get one of these to play with a little bit. And this is kind of an example. So you can see it came like this from Banggood. This part up here is the Stirling engine. It has a weighted flywheel, and then there's a little pulley, and it connects to a little tiny electric generator. So this kind of is a proof of concept. So let's fire it up and see how it works. Alright, so I have a little container of just plain old denatured alcohol. You can buy this in the hardware store or wherever. The kind of alcohol you would use in a Bunsen burner or something like that. And it comes in this little container. You just pour it in here. And you place the wick inside there, and that kind of soaks up the alcohol. And then we place this under here. And let me see if I can find a lighter. Okay, after the great lighter search of 2018 has concluded, we can now light this. And you can see that this is a little bit faster to start up, obviously, than boiling water for a steam engine, but it is certainly not as fast at starting as a internal combustion engine like a gasoline or diesel type engine. So you have to wait till the air inside this cylinder heats to a certain temperature, and eventually it will start to move. And to make the engine more efficient, we could even put a piece of ice on this to cool this side. So you have the greater the temperature differential between these two cylinders, the better the motor will work. So let's see. Not quite yet. There it goes. And you can see, just with using heat and no other fuel, just the fuel to create the heat, we can make this motor run. Now, anything that produces heat will make this engine work. We could submerge this in hot water, or like we said, we can use the geothermal idea. And I don't know why we haven't really pursued this a lot more for electrical power. So let's take a look at what this little motor's putting out, if we get any kind of output at all. Okay, I hope we have everything in shot here. So let's connect this meter up. And you can see it's not very efficient. It puts out a little bit. We're only getting about 1.7 volts DC. And if we hook it up to an oscilloscope, I'm pretty sure it's not going to be a very clean DC, because obviously this reciprocating engine does have a little bit of, it's not really very smooth. But the warmer this air gets here, the faster this will rotate. The faster it rotates, the more energy the little motor can produce. So now we're up to 2 volts. You can see it's getting faster and faster. But here's the problem. We all know when you place a resistive load on a generator, that generator will cause some back EMF, and that back EMF will actually cause the motor to slow down, to slow the engine down, because it'll put a load on this motor and slow it down. So little things like an LED, let's see if we can get the LED to light, will work. And you can see how the light kind of flickers? No, you can't, because I'm off. Here we go. You see how the light kind of flickers? I don't know if you can see that on the camera or not, but it's actually flickering quite a bit here in real life. And that's just because of the way that it's not turning very smoothly. And if you whenever you put anything on there, I don't know if did you hear that? Just that little bulb by itself, that little LED, slowed the motor RPM down. So listen to the motor, and it slows down. I don't know if you can hear that. So you really can't produce a whole lot of power. So the way this is working right now, not very efficient. But the fact that we can use geothermal energy to run one of these, any amount of output that you get, because there's really not much in the line of maintenance on these other than making sure they're lubricated and so forth, would be very cheap source of energy once you built the device. So I don't know, give me your thoughts on this. I just thought it was kind of interesting, and waste 10 minutes of your time here watching this, but I just thought it was pretty cool. Alright, so another thing I want to do in this video is kind of introduce you to a new member of the bench here. And as you can tell, it says Spectrum Analyzer. And yes, this is on the bench monitor. And what we have is a new Spectrum Analyzer, and you can see it up here. And it is an ON XSA 1015 TG with tracking generator. I've been using it now for about a month, and I have to admit I really like it. It seems to be pretty similar to the Siglent unit that's out there. And so far, I couldn't be happier with it for the price. And the thing I really liked about it is that it has a VGA output so that we can share the video on large screen on the bench monitor. So when we're working on some RF equipment where we're going to need to use a spectrum analyzer, this is going to make it a lot easier for us to kind of see what's going on, because I can zoom right in on this thing and we can really see what's going on. So just thought it'd be a neat little thing to show you. But you will be seeing this moving forward whenever we work on some RF equipment. So I just thought I'd show that to you real quick. All right, so let's move on to a few of the questions and comments. The first thing we're going to look at is this gazillion comments I got on the last video I just did, which is that PV CS1200 amplifier. First thing I'll let you all know is that normally I probably would put that one up for sale because I really don't have a use for a commercial amp. I don't play in bands anymore or do anything like that. Plus, I just have too much stuff. Need to thin the herd. So, but I do have a cousin who is a DJ, and he does it professionally, and he saw that and kind of said, wow, he has some other CS series amplifiers and so forth. So I've decided I'm just going to give it to him. I think it would be a good addition to his rack system, and he definitely will put it to good use, and it'll hopefully have many years of good use doing what it was designed to do, commercial audio. So that's what we're going to do with that. I want to look at several of the questions I had, and this one here was a really good one. I get this one all the time on a lot of my videos that I feature this. So he basically said that moving the power resistor from the board to the more remote location is a good idea, but are you sure these little yellow skinny wires can take the load? And what he's talking about is when I moved the dropping resistor that drops the voltage down for the fan. So if you recall on this video, there's a big power resistor. It was a big ceramic power resistor, and it was in there in order to drop the voltage down on the fan to make the fan run at slower speeds. And then what would happen is there's a triac that if you gate the triac on, it essentially would just short out that resistor, allowing the full 120 volts AC into the fan to make it run at full speed. It makes it very loud. So it basically is for making the fan run quieter. But the problem is the way that ceramic resistor, if you go through this video, and again we're talking about the CS1200 video up here, that resistor would get so hot it would actually char the circuit board and even kind of cook the capacitors that are adjacent to it. So what I did was I moved that resistor off that board and mounted it to the chassis, and I ran it using these little wires, and they're kind of thin. You can see how thin this wire is compared to this little pointer, but this is not what you think it is. I use this wire a lot, especially in places where there will be a lot of heat and so forth involved. And what these wires are, first thing we'll do is we'll get down and kind of look at the spool. Here's the label that comes on it. This is where you can get them from, and you can buy this on eBay, and I think you can also buy it on Amazon. And what this is it is a Teflon coated wire. So this is like a PTFE Teflon. It's very strong. It's very hard to cut. It's very hard to strip this wire. It is very heat resistant. So if you take your soldering iron and you put it on here, it won't burn. Okay, it doesn't do anything to it at all. Whereas if you touch a regular piece of wire, let's see if I have a little piece of wire here. Hold on. Just this vinyl type of wire, immediately you can see it starts burning almost instantly. See the smoke? So number one, it is very well suited to environments where you're going to have a lot of heat. The other thing is, let's strip this, which is not always the easiest thing to do. If you notice, this wire is not colored like normal copper wire. So if we look at copper wire, here's your copper wire, okay? Here's this stuff. You can see the difference. And it's very fine strands, and it's silver coated. This is actual silver coated wire. So even though it's thin in diameter, it actually has better conductivity than this copper wire. So you can use a smaller piece of a thinner gauge of this to carry as much energy as a heavier gauge. And if you look, even though these are kind of different diameters of wire on the outside, you can see how much different they are. The inside conductor is the same. The difference is that this vinyl coating, which is what a lot of the cheaper wire out there has to be thicker because, number one, it can easily be cut, and number two, it is very susceptible to heat. It can melt very easily if you touch it with your soldering iron or anything like that. So this is one of those things where looks can be deceiving, but this is actually very good quality wire, and that's why I use it. Again, I don't use it for everything, but anytime I'm going to be connecting to a power resistor, or a lot of times when I'm wiring up a socket in a vacuum tube amplifier. Remember, vacuum tubes use relatively low current, but there are relatively high voltages. The other thing is, this wire is good up to 500 or 600 volts. Even though it's a very thin coating, it has very good insulating capabilities with this Teflon coating. So it's very good stuff. So I hope that answers that question. Okay, likewise, I've had quite a few comments on this video, more so than others, but pretty much every troubleshooting video that I do, I'll get several comments, and I'll just paraphrase what most of them will say is, well, gee, you took an hour to troubleshoot this thing, and all you really need to do to troubleshoot this, you're doing it the wrong way. You could just check this one component or do this, that, or the other thing. You fill in the blank. I just kind of want to number one, please leave those comments, because the more people know about how to do certain things, you know, the more it's going to benefit all of us, you know, when we see different people's techniques of troubleshooting. A lot of times when I do these videos, I'm really not doing them to be the most efficient or the fastest way. I'm trying to demonstrate kind of a walkthrough of how you troubleshoot something logically. So sometimes I may do some extra steps in there that you may not need if you really understand how something works, or you may not need if you've worked on these before and already know basically how to service this type of thing. And because of that, it can make it look like I'm taking the long way around. And I am taking the long way around. But again, part of the reason that I do these videos is to share with others some of my ideas of how I troubleshoot things and so forth. And kind of for those who maybe don't have as much experience at things and they want to be able to figure something out. They're going to see something they haven't seen in the past, and kind of, how do I logically approach this to be able to troubleshoot it? So I'll put some extra steps in there, and sometimes the troubleshooting isn't really troubleshooting. I'm doing something because in the very end you're going to find out this is how something works and this is why. And I'm kind of demonstrating how something works. So there's so many videos out there from other YouTubers that is, if this thing's broken, this is the transistor that always goes bad, and here I'm going to solder the new transistor in and replace it. And really, some people that maybe have something, they're looking for a shortcut like that. They're not interested in learning how the device works or how to troubleshoot it. They just want to know, what do I do to make it work? And they watch one of my videos and they get very frustrated and say, well, heck, 2 hours into this, or an hour or 40 minutes of watching this, and you could have just told me that in the beginning, you know. Well, I apologize to all of you who are looking for that, but I'm just going to let you know up front that's really not the purpose of my channel or of most of my videos. I want to try to kind of walk through how things work and how we approach things. And sometimes I may be working on something that's new to me, and I'm doing that process of discovering and learning, and I'm sharing it with you on the video. So I hope you understand that, and I hope that kind of clears the water with that a little bit. Certainly, if there's something you really need to know, email me. I love the comments, because comments, everybody gets to read them, and if you're sharing something that's useful, everybody gets to benefit from it when you put it in the comments. But if there's something you really just need to know, and somehow I can help you in some way, if from what I know I can help you, please email me, because I don't always have the time to read all of these comments. And even if I do read all the comments, I don't always have time to respond on them through YouTube. So you have a better chance, if you have a question, to email me than if you try to pose a question on the comments section like this. Again, usually about one day a week or one day every 2 weeks, usually on the weekend or something, I'll try to go through all of my emails and try to answer as many of them as I can. So that's your best bet if you need to communicate with me as far as something like that. So I hope that helps with that. Now, another big question / comment that I get a lot is, I get two of them that are recurring a lot. The question number one is, gee, I love this video that you did on this, and I have one of these receivers or amplifiers or whatever. Can you fix it for me? Do you take on jobs? And the short answer to that is sometimes I do. Again, if you have something and you would like me to work on it for you, to service it, to do a refurbish or restore or something, email me. If I have time and it's something interesting, I may decide to take the job on. Okay, so a lot of the things you see on the bench are things that others have sent in. Now, the criteria I usually use is, number one, is it something that perhaps is new and different, that maybe is something I'm interested in working on or I enjoy working on, or maybe it's something that I may see something interesting that all of you may enjoy seeing, and that I can do a video of, and it's something that perhaps I have not done on this channel yet. So something new that I could share with everybody. So that might be one reason that I would be willing to take on another job. Just so you understand, I'm usually booked 6 to 8 months in advance with projects. If I cut everything off right now, I have enough material to do videos and be working at the bench here very easily for the next year. So there's a lot of things that have been sitting for a very, very long time that don't belong to other people that I just haven't had time to look at. The other question I have is, if I mention that it's like this CS 1200, that I purchased it and I own it, a lot of people will comment and say, hey, can I buy this? Are you selling this? How much do you want for this? Again, the best way to inquire about something like that would be to email me. And in some instances, it's something that I'm going to keep in my collection or share with one of my family members or friends or somebody else. But in some instances, I do sell a lot of it. So if you email me, I can let you know that either A, it belongs to someone else, or B, it's something I'm going to hang on to, or C, yes, I'm interested in selling it. I do have equipment. Even now I have equipment that I would sell, just because I have too much stuff. You can't be a pack rat. You have to get rid of some stuff and thin the herd, So I hope that answers that question. So really, this video really wasn't much about anything other than that. I just wanted to answer those couple of recurring questions that I get in comments that I get, and hopefully, and also apologize for not posting videos as often as I normally do. Typically, I try to get something up once a week, but we have been absolutely swamped with work. This has been, running the numbers, this has been the busiest year that my company has had since we opened our doors. So that's been 8 years ago. So been taking up a lot of my time. But anyway, we're going to try to get more time at the bench. And as I told you, we have some really good projects coming up here. I have one I'm working on right now, so hopefully we'll get something up shortly after I get this video up. And till next time, peace, joy, happiness, and good health in all your lives. And I'm glad you all came along with me. Thank you so much for all of the wonderful comments, for the donations that you've made to my channel. And no, I don't have a Patreon. Really, I don't do this for the money. I do it because I enjoy it. And I do it because I try to share with others what I know, because so many have shared on YouTube what they know, and I have benefited greatly from that over the years. And I feel that it's only proper that if I have some little bit of knowledge that's not as good as everybody else, but something I can offer, I feel that it's my obligation to give back, because so much was given to me, I feel, through YouTube and through all the hard work and time that people spend shooting videos for me and you. So anyway, thank you all. I appreciate everything. And until next time, stay well, and more to come very soon. Bye-bye.